Okay, so let's take a look at this example here. We have the integral of 4x squared minus 9 dx. 4x squared minus 9 dx. So once again, let me pull up my integration tables. You might recall when we were going through these before, we had integrals involving a squared plus x squared. This doesn't have that. This was a difference. So if I go back to the previous page, we have integrals involving x squared minus a squared, or a square minus a square. So that's the one we're looking for, and we see that formula 68 is the one we want. Formula 68 is a bit of a bear, a bit of a mess. It says the integral of the square root of x squared minus a squared, x squared minus a squared dx is equal to x over 2 square root x squared minus a squared minus a squared over 2 times the ln of the absolute value of x plus the square root of x squared minus a squared. Plus a constant. So just taking formula 68 as it was, x over 2 square root of x squared minus a squared over 2 ln absolute value of x plus square root of a squared, x squared minus a squared, plus a constant. Okay, so if we look at our formula, it's not an x squared minus a squared, right? It's got a number in front of x squared, and our formula says we can't have that. We can't have that. So we do have to here do some work first to modify it. We do have to do some work first to modify it. So what I would do is take my integral here, and since I need an x squared only, I can factor a 4 out. So square root of 4 times x squared minus 9 over 4. Right? Dx. And now this thing fits the right format. Square root of 4 we can take out. Square root of 4 is 2. So I have 2 integral square root of x squared minus 9 over 4 dx. So we now recognize that a is 9 over 4, or a squared rather, is 9 over 4. And I just need a squared because as I look at this integral, everything that I need is an a squared. Everything I need is an a squared. Okay, so now it's in the right format. So because this is all multiplying by 2, those halves that were involved in that formula can both just disappear. And so I'm just going to drop them out of the problem. And so I will have x over 2, but it's times 2, so the 2 goes away. So I just have x times the square root of x squared minus 9 over 4. And then minus a squared over 2, but again it's times 2, so it's just a squared. So minus 9 over 4 ln absolute value of x plus the square root of x squared minus 9 over 4 plus a constant. Okay, so we're able to work the integral out. We're able to work the integral out. So with this integral, though, square root of 4x squared minus 9, we actually could work this out ourselves, right? And so I actually want to go back and look at that one by hand because it does review one of our trig substitutions. Okay. And then we're going to compare our result to the given result and see that they're actually the same. They're actually going to be the same. They look a little different at first, but they will be the same. So let's turn now to the other part of this problem. Let's do this problem now without that integration table formula. So let's go back and check that out. Integral 4x squared minus 9. This is u squared minus a squared. U squared minus a squared. Right, so this is fitting that format for a secant substitution. Right, for a secant substitution. Right, because this is really the integral of 2x squared minus 3 squared. So we can do the substitution 2x equals a secant theta. And we can differentiate. And when I do that, I would get 2 dx, but I'm going to divide by the 2, so I'm going to get 3 over 2 derivative of secant, which is secant tangent d theta. So now I'm ready to carry that substitution through. Integral of the square root of 9 secant squared theta minus 9 times 3/2 secant theta tangent theta d theta. Okay. But remember that this 9 secant squared minus 9, you can factor the 9 out. You can factor the 9 out. We have square root of 9, which is 3. That'll join with the 3/2. So I'm going to put all that out front, 9/2. And then that would be secant squared minus 1. But secant squared minus 1 is tangent squared. So we'd have a tangent squared inside the square root. Square root of tangent squared would be tangent. So that in the end we're going to have secant theta tangent squared theta d theta. And unfortunately, now I do not have a secant left over, so secant tangent with a tangent left over won't work. For tangent substitution, I need a secant squared. So all I can do here is transform the tangent into a secant squared theta minus 1. And that would make my integral be 9/2 integral of secant cubed theta minus secant theta d theta. And that means we have to use, our reduction formulas. That means we're going to have to use our reduction formulas. So I would come in here and use the reduction formula on secant cubed. Recall what that formula is, so let me just pull up the old notes from 8.3. Right, our secant reduction formula. Find that here. Here it is. Secant to the nth power is secant dropped by 2 powers along with tangent over n minus 1, and then plus n minus 2 over n minus 1 secant of 2 powers smaller. Secant of 2 powers smaller. Okay? So in our case, n is 3, so that would be secant of 3 minus 2, or secant to the first, along with tangent, all over 3 minus 1, which would be 2, and then that would be 1/2 integral of secant to the first now. Okay, so in our problem here, using our reduction formula for secant, this would be 9/2 times, again, secant dropped by 2, tangent, over 3 minus 1, which is 2, plus 1/2 integral of secant 3 minus 2, so secant theta d theta. Okay, and then don't forget that this is also then minus 9/2 the integral of secant theta d theta. So this part we could clean up here. This part we could clean up, right? This part we could clean up. 1/2 minus 9/2. Actually, it's 1/2 times 9/2 will actually be 9/4 minus 9/2, which will be a negative 9/4. Okay, so that's going to be a negative 9/4 integral secant theta d theta. And then we remember what the integral of secant theta is. Okay, or how to find that, one of the two. So putting everything together, 9/2 times the half there will give me 9/4 secant theta tangent theta minus 9/4. And then remember the integral of secant theta is ln of secant theta plus tangent theta, and then plus our constant. So the final piece to this puzzle is we have to convert it back to x. So we remember now that 2x was equal to 3 secant theta, so we solved that for secant theta. Right, that gives us that 2x over 3 is equal to secant theta. We then draw the picture for secant theta. Draw the angle generally here in the first quadrant. Secant, remember, is reciprocal cosine. Cosine is opposite over hypotenuse. So secant will be hypotenuse over, cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. Then we use Pythagorean theorem to finish the third side, which would just be square root of 4x squared minus 9. Square root of 4x squared minus 9. And we do that because I need to be able to talk about the tangent. I need to be able to talk about the tangent function. So returning to my problem here, this would be 9/4 times the secant, which is 2x over 3, times the tangent, which would be the square root of 4x squared minus 9, all that over 3, minus 9 over 4, ln absolute value of the secant, which is 2x over 3, plus the tangent, which would be square root of that stuff over 3, or alternatively 1/3 square root of 4x squared minus 9, and then of course plus our constant. Okay, breathe a little sigh of relief. We have gotten through this problem, which definitely could be a test question on the test with this kind of stuff, using your trig substitutions. So we did this, of course, first off with the integration table, and we got this answer. What I want you to realize that this answer and my answer are essentially the same. Okay, and let me explain to you why that is. So first off, I didn't do any cleaning here, but a lot of stuff, if we simplified it, I'm just going to leave it as this for now because it's good enough. Notice the 3's will cancel there. The 2 will cancel with the 4 and leave a 2 left. Now, if you go back to the formula up above, it was x and the square root of x squared minus 9/4. So once I've canceled out the 9 and the 3's, you notice I have my x left and a square root. If I took the 4 out of that square root, I'd have square root of 4 x squared minus 9/4. The square root of 4 would be 2, and that would then cancel with the remaining 2 that was left in the bottom there. So that you would just have x square root x squared minus 9/4, just like we had up above. And in a similar fashion, you can equate that stuff here as well. Because what you would do here is, once again, factor the 4 out. Take the 4 outside of the square root, you'd have another 2/3 square root x squared minus 9/4. What you can then do is factor out the 2/3 from the whole absolute value. Factor out the 2/3 from the whole absolute, or whole ln of absolute value. And then you'd have ln of 2/3 times the absolute value of just x plus square root of x squared minus 9/4. Okay. You just have x plus square root of x squared minus 9/4, and you have a 2/3. But ln of 2/3 is just another constant. So the constant's just different. So this thing is going to be the same as our original problem, just with a different constant. And that'll often happen with these integration tables. As opposed to doing it in an alternative method, you get the right answer, but it's off by a constant. And that's okay for an indefinite integral.